to see them. So this is the number 5. On number 5, we've been given angle, angle, side. And you know the law of sines, you need to have one side and opposite angle that you know them both, and we do. And then we can solve for the this side, which is across from the second angle. So let's set it up like that. C divided by the sine of C equals B divided by the sine of B. Fill in what you can fill in for. C divided by the sine of 105 equals 20 divided by the sine of 45. Okay, so C equals 20 times the sine of 105 divided by the sine of 45. So I'm doing this calculator work in my hand. So 20 sine 105 divided by sine 45. And I'm getting 27.3. Now angle A we could figure out because we know the other two angles in the triangle, so that should be 180 minus 105 plus 45. You know, these two, 105 plus 45 is 150, so this is 30 degrees. So now we can set up to solve for side A. A over the sine of A equals B over the sine of B. So A over the sine of 30 equals 20 over the sine of 45. So A equals 20 times the sine of 30 divided by the sine of 45 degrees. So again, you could do that in your calculator, 20 sine 30 divided by the sine of 45. 14.1. And just let's make sure the biggest angle is across from the biggest side. The smallest angle is across from the smallest side. So at least it makes sense. Okay. This is the number 6, for which you didn't have an answer. In this case, we've got an angle, and then a side, and then an angle. And again, to use the law of sines, we need to have one side and opposite angle that you know both. And right now we don't, but it's a pretty easy fix because these two sides plus this side add up to 180. This is 75, so this is 105 degrees, right? That's your 180 minus 35 plus 40. Okay, now we still have to find side A and side B. So it's pretty straightforward at this point. We'll just say, I'm not gonna write the formula. I'm just gonna fill in right away just to save a little time here. A divided by the sine of 35 equals 10 over the sine of 105. So A equals 10 sine 35 divided by the sine of 105. 5.938. I'll just say 5.9. That was A. And now we repeat this time for B, right? B over the sine of 40 equals 10 over the sine of 105. So B equals 10 sine 40 divided by the sine of 105. .65, I'll call that 6.7. So does it pass the first test? Do we have biggest side across from the biggest angle? Looks like it. The smallest angle is 35. It looks like A is the smallest side, so I think we're on track. Okay, now these next couple, we're definitely dealing with a side-side angle. I didn't label this. This is going to be A, which makes this little a. This is going to be B, which no, that's wrong. Sorry about that. This is C, this is B, and this is B. So we've been given side A and B and angle A. So we've been given this part, and this part, and this part. And we have to solve for the triangle. Now, the angle that we've been given is obtuse. It's 110 degrees. And we didn't do much with this in class, honestly, because it's pretty basic. We still, as always, when you know side-side angle, the way you're going to work that out is you're going to say it'll be sine of B over B equals the sine of A over A. And the sine of B over B, well, let me label this as 125. This one is 100. This one is 110. So the sine of B over 100 equals the sine of 110 over 125. Okay, so the sine of B equals 100 sine of 110 divided by 125. So put that in the calculator. 100 sine 110 divided by 125. 0.7517, I'm going to call it 0.7518, which means that the B is the sine inverse of that second sine inverse, second answer, 48.7. So it looks like we do have a triangle, and this is 48.7 degrees. And then we can do 180 minus to figure out this angle. Should be 158.7, 158.7, 180 minus that would be 21.3. And then we still need to find which one. We still need to find the side C. Okay, so C over the sine of 21.3 equals, and I'll say 125 divided by the sine of 110. So C equals 125 times the sine of 21.3 divided by the sine of 110 degrees. And that I can put in the calculator. And I'm getting 48.3. And again, the biggest side looks like it's across from the biggest angle. The smallest side is across from the smallest angle. So it doesn't violate any first principles here. Now, in this one, it's another obtuse angle, right? This is A, this is B, and this is A. 125. And B is 200. And A is 110. So first step, we're going to solve for angle B. The sine of B divided by 200 equals the sine of 110 divided by 125. So the sine of B equals 200 times the sine of 110 divided by 125. So the sine of B equals 200 sine 110 divided by 125. 1.5 something. 1.5. Now, it is not possible for the sine to equal 1.5. Remember that the sine has a range of -1 to 1. If you try to do the sine inverse, you're going to get an error. You don't really need to take that step. At this step, you just say, can't be, because sine can't equal 1.5. Now, if you go back to the lesson, there was two situations for an obtuse angle being the given angle in a side-side angle scenario. In one of them, A is greater than B, okay? And that's what we had in the number 25. A was greater than B, so that meant it could reach the third side, the other side of the 110-degree angle. The other situation was if A is equal or less than B, then you're not going to be able to form a triangle. There's no way for this side to reach down if A is less than B. I mean, if you just let this side swing this way, you could tell that it's not going to be long enough to reach to the other side of the angle. So no triangle. But if you don't see that, if you're not remembering all those criteria that we were given, it's enough just go ahead and solve it like you solve it. And when you get to this point here, you'll know that you have no triangle. Okay, so just set them up using the laws of sines and get as far as you can. Okay, now we've got another side-side angle. Now we've got 76 degrees for A. B equals 20. A equals 18. And okay, we have to start by solving for this angle B right there. So, and I'm gonna skip the step of writing the formula, which I don't like doing that because I think it's always important to do that. But I think this is going to be the one where we get two answers. I remember that you get two answers if A is less than B, which it is, and A is also greater than the height of the triangle. And I don't know that for sure. I could figure it out, but I don't really care. I'm just going to go ahead and do it because that's the way I usually do these. If you find it easier to find the H, then by all means you could do that. So let me find the sine of B over 20 equals the sine of 76 over 18. So sine of B equals 20 times the sine of 76 divided by 18. Okay, I can put that in the calculator. 20 sine 76 divided by 18. 1.078. So in fact, unless I did something wrong, so this is not one of those that I get two triangles. This is one where I don't get any triangle. So 1.08. I would just call it 1.1 because it really doesn't matter, right? Because that number is not in the range of sine. So no triangle. 76, 18, 20. So I set all the sine of b over 20, sine 76 of a. So that was all right. So maybe it's the next one, which was the two solutions. No, it's not. Well, I think that's kind of a mistake on my part because I really thought we were going to have one that had two solutions. In fact, I thought I was looking in the back of the book and checking to make sure I gave something of all kinds. That was 28. I'm checking. What you can't see is I'm checking right here. So we're on .408 .408, and that was number 27. 27. Yeah, 27 was no solution. Well, darn it. I should have given you one where you had two solutions, and I guess I didn't. Okay, so now we can move on to number 28. And 28, we've got angle A is 76. Side A is 34. Side B is 21. Okay, so let's find side angle B first. Always the first step. Sine of B divided by 21 equals sine of 76 divided by.
Anyone left in the building, please leave at this time. All faculty and staff need to exit the building at this time. The building needs to be secure. Thank you.
Okay, so the sine of B equals 21 sine 76 divided by 34. .5993. And if you notice, I do tend when I'm solving for the sine, then I tend to keep a lot of decimal places there because I think it'll make a difference in the angle. You know, a small difference in this will make a big difference in the angle, or it could. So that's why I do that. In fact, when I do it with a calculator, I really just let the calculator fill in the answer. So B is the sine inverse of 0.5993. Second, sine inverse, second answer, 36.8. Right, so this one is 36.8. That means C is 180 minus those two. See, 76, 112.8. Is that correct? 112.8, 180 minus would be 67.2. Hopefully that all works out. Okay, so we still have to find C. C divided by the sine of 67.2 equals 34 divided by the sine of 76. So C equals 34 sine 67.2 over the sine of 76. Put that in the calculator. 34 sine 67.2 divided by sine 76. 32.3. And all the angles and sides look like they're appropriate. Okay, now we've got our word problems at the end. Hope you didn't hear that. Okay, because of prevailing winds, a tree grew so that it was leaning 4 degrees from the vertical. At a point 40 meters from the tree, the angle of elevation to the top of the tree is 30 degrees. Okay, find the height of the tree. All right, so here's our triangle. We're finding the height of the tree, which is this side. We know that this angle is 94 degrees because the tree is leaning 4 degrees beyond the vertical. Right, the vertical would be straight up and down here. So we know that side. So what do we know? We know an angle, side, angle. Okay, in order to use the law of sines, I need to know one side and an opposite angle. And since I only know this side, I must have to know this angle. So use 180 minus to find that. And these two together are 124. So that would make this 56 degrees. Right. Okay, now I know what I need to find h. H over the sine of 30 equals 40 over the sine of 56. So h equals 40 sine 30 divided by the sine of 56. Number crunch that. $24.1. 24.1, and it looks like we are talking about meters. 24.1, it's about 3 feet per meter. That's a pretty tall tree. Okay, flight path. This one we looked at in class, but we didn't finish it. So I'll go ahead and finish it here. Okay, a plane flies 500 kilometers with a bearing of 316 degrees from Naples to Elgin. Okay, this use of bearing is not what we've been taught about how to use bearing, but they did label it. I mean, we're talking about a direction from Naples to Elgin, and I don't see any 316 degrees, but what I do see is 44, which is 360 minus. So they must mean that they have gone all the way around this way. That's 316 degrees. Okay, the plane then flies 720 kilometers from Elgin to Canton, which is due west, right? Which is due west, which tells you that this angle here is a 90-degree angle. Okay, find the bearing of the flight from Elgin to Canton. So find the bearing from this place to this place. Well, we understand bearing again to be the number of degrees east or west of a straight north-south line. So let's find that the way we understand it. And then, because we understand that they're actually using bearing in a little bit different way, then we'll go ahead and report it the way they report it. So now looking at this picture here, here's our triangle. We know two sides. We need to know the included angle here in order to know the bearing. Let's see. We don't know any of the angles inside the triangle now, but if these two, right, this 44 degrees and this angle, which is in the triangle, add up to 90, then you know this is 46 degrees. So what can we find now? We know this angle and opposite side. We know this side. That means we'll have to find angle C, or the angle at Canton first. So I'll just call that C, right? Sine of C divided by 500 equals the sine of 46 degrees divided by 720. So the sine of C equals 500 sine 46 divided by the 720. Right? The sine of C equals, put that in your calculator, 0.4995. So that means that C, which is the sine inverse of that, second sine inverse, second enter 29.96. I'm going to call that approximately 30 degrees. So if this is 30 degrees, right, we need to know this angle here. Well, I mean, this is a straight north-south line. This is a straight east-west line. That's 90 degrees. So if that's 30, that's 60. So in terms of the bearing that we've been taught so far, we would say this is south 60 degrees to the west, right? South 60 degrees west. In terms of how they gave the bearing in the first part of this problem, then we would need to know, well, how many degrees is it if I started straight north and I went around that way? And that would be 180 to go halfway around the circle, plus another 60, which is 240 degrees. And the last homework problem, right? The bearing from the Pine Knob Fire Tower to the Colt Station Fire Tower is north 65 degrees east. Okay, well, at least this time they're giving it, this is the way we understand bearing. North 65 degrees to the east. And the two towers are 30 kilometers apart. Okay, that's labeled. Okay, a fire spotted by the rangers in each tower has a bearing of north 80 degrees to the west, to the east from Pine Knob, and south 70 degrees to the east from Colt Station. Find the distance of the fire from each tower. So if I call this my capital P for Pine Tower, and this can be my capital C for Colt Station, and this is capital F for the fire, then we're being asked to find the little c, the side across from capital C, and the little, let's see, we already got that, and the little p. Okay, let's see, what pieces of the triangle do we know right now? The first thing we know, I mean, here's our triangle. Besides that one side, that's all we know. We're probably going to figure out two other angles, though, by doing this. If this big angle is 80 and the smaller angle is 65, then this angle here is the difference, which is 15 degrees. So there's one. Okay, and then in order to know what this angle here is, if you can see the way the pen's moving, we know that this 65 degree angle and this angle here are alternate interior angles between parallel lines, because these are both straight north-south lines. So if this is 65, then this is 65. And that means that the entire angle on this side is 135 degrees. So we do know we do know what we need to figure out these two sides. So we're just going to have to do it one at a time. I'll start with the side P. Right? P over the sine of 15 equals, or do I need to do one more thing? Oh, I need to do one more thing, which is to figure out what this angle is. That would be 135 plus 15, which is 150, so that is 30 degrees. Okay, so now I'm ready. 30 divided by the sine of 30. So put that in the calculator. 30 sine 15 divided by sine 30. 15.5. Okay, that was P, so that's here. Okay, now we need to do the same thing for this little c. Little c divided by the sine of 135 equals, same right-hand side, 30 over the sine of 30. So c equals 30 times the sine of 135 divided by the sine of 30. And I'm getting 42.4. So that would be equals 42.4, which seems reasonable.